Hi, my name is Naser. I am real-time visual effects artist. Today we want to talk about Niagara, not in a very complicated way. We want to understand this system very simply. So, to begin with, I need to create a Niagara system in FX section. We have four choices here. I choose the last option, create empty system. I rename it to Niagara system. Well, I leave it at our level. I open the Niagara. We have a viewport here. We have a timeline. We have a parameter, system overview. Selection means that whatever we choose here, its setting and parameter will be display here. We have attribute spreadsheet here. We can see the attribute of particle in here. So about this blue box, this is a Niagara system. There are a series of general settings here. The most important part is located here in this part here. If we pay close attention, it tells us that this is looping behavior of your system is running permanently, and the loop length is 5 seconds. This means this system starts running every 5 seconds. So now we need the emitter to start. I right click here and we can add an emitter here. We select the empty emitter. We make an emitter here, and as you can see, timeline start to move. Our timeline range is up to 10 seconds. Here we have a green section that the emitter runs on 240 frames. That is 1 second. Now what is this 1 second? I can say here we have a bug, but maybe this is one of the Niagara issue or problems. Now, because we don't have 1 second here, but if I click on this section, it tells us that life cycle mode is called from the system. It's called from here. That is, if we have more emitter, they receive this section from the system. But if we choose self here, let's say that the life cycle data of this emitter should be defined with itself. And now we have 1 second here, and as you can see, if I increase this number, this part will also be more. Now I want to give a general explanation about this emitter. If I pay attention to the emitter is divided into 4 main parts. This is first part. The second, third, and the last part. That means we have 4 sections here: section 1, section 2, section 3, and section 4. Now I want to talk about these sections. So if we have one particle, this particle has a series of attributes. First of all, there is a particle here. So I can say that this part is about the presence of this particle. For example, what information about this presence of this particle is important here? One is the number of particles. For example, we have 3 particles here, and how much is the loop duration for each of these particles. This is the second attribute we can define in this section. Either these particles are made by CPU or GPU. For example, do this particle each have a specific ID or not? So this section gives us the information that particles need before they are spawning. The next part is particle spawn. This section or this part tell us now the particles have been created, what are their attributes. For example, we have the lifetime here, which means that each particle exists for a few seconds, for example 5 seconds. We have a color, size, and etc. The name of the next section is particle update. Here we can change the attributes of the particles over the time. For example, if here we set the size to 10 for this particle, this means that at the moment of creation the size of this particle is 10. But if we want to change the size, we have to do it in this section. And this part is related to rendering. That is, this section specifies how the particle will be displayed in viewport or in your level. There is something very important here is the movement of attribute along the system. For example, I say here we have a lifetime attribute. It means this particle has an attribute, call it lifetime, and this attribute is stored in this particle. The movement of attributes in this emitter is from top to bottom, not from the bottom to top. That is, if we define an attribute here, we can use it in the lower part. But we can use the attributes we define here in the above part. Well, that's it. I hope you enjoyed this part. In the next section, we'll start and create a new system.